How you going, guys? Curtis from Cutting Edge Engineering. This is part 2 of our 785 hoist cylinder rebarrel. If you've missed part 1, there'll be a link in the description below. Now that all the welding is complete on this end of the barrel and it's cooled down enough, we can take it back over and set it up in the lathe. Righto, so it's set up in the lathe again now. What I need to do is bore out the area where I have put the weld on the inside of the head flange to bring it down to the size of the barrel. Then once that has been done, the two can be honed together. So because we couldn't pass the tube through the head flange, we had to cut the inside of the head flange down and then build it up with weld, and then we'll bore it and then hone them both to size. Righto guys, so the machining is now complete on this end. What I need to do is flip this in the lathe. I have 120 mil of material to part off the other end. The reason I got 120 left over is I anticipated machining the head flange and fitting it over the barrel. It didn't work out in this case, so we'll flip it in the machine, part that end off, and then I can turn the O down. So that's all the machining done. Before I can fit the barrel end, I need to hone the ID of the barrel to size. So we need to set it up in our Delapena vertical hone.
What about that one? Oh. Come on. Okay.
Righto guys, so we've got our barrel set up in our 1960s Delapena honing machine. If you haven't seen this before, we have a video where we do a walk around the machine and tell you a little bit about its history. So the maximum stroke of this machine is 1300 mil. When it came from the factory, it had about 870. I already extended the machine once where I made new guide rods, drive shafts and cylinders. The barrel itself is 1275, so it is maxed out. There is nothing left in it. To measure the bore during the honing process, we'll be using a dial bore gauge. So the way I set these, I use a set of outside micrometers. I set them to my finished size that the bore needs to be, and then I put them over the anvils on the bore gauge, and then I zero out the dial. We'll do that in order to get it close. Once we start getting the material out of the barrel and we're ready to finish it off, we will then reset the bore gauge in case anything's been bumped during the measuring process, and then we will check it from there. And we're going to be using Sun & Tooling. It is a Sun & remote feed portable honing head, and we'll be using Sun & stones. During the honing process, we're going to go through 4 different types of stones. We're going to start with our 25s, which are a great stone for getting a barrel round. So if it's got any high or low spots in it, that'll remove those. We then move up to a 47, which is a very hard stone but very coarse. After the 47s are done, we'll put in the 45s, which are a much softer stone. They're great for bulking out material. And then once we get the barrel to within size, we'll put in our 87s, which are our finishing stones. So I've got about 1 mil of material to remove out of this barrel in order to get it up to its 11.5 inches. So we're going to get started on it. So that's the set of 25 stones done. They lasted about 10 minutes, but they did their job. They got the barrel nice and round, so we'll change them over to some 47s. There's going to be a couple of sets of 47s go through this in order to bulk out as much material as we can, but you do need to be careful with the 47s, being that they are so hard, you can actually overcut your barrel pretty quickly with them. After we're finished with the 47s and we're pretty close to size, we'll throw some 45s in there, we'll finish it off to within 0.1 of a mil, and then we can finish it out with our 87s. Righto guys, so we've got the barrel completely roughed out now. I've only got about 0.01 of a mil to remove. So we'll take the hone out, we'll change out from our 45s down to our 87s, which are our finishing stone, and then we'll continue honing to get the surface finish required for a hydraulic cylinder. Righto guys, so the honing on the barrel is now finished. We are exactly 11.5 inches, so we couldn't ask for any better than that. So what I'm going to do, I'm going to let this drain off, let all the oil drain back into the pan. After that we can take it out and go set it back up in the lathe. So that's been draining for a while now. All the material has drained off into the pan. Once it's in the pan, it gets pumped up into the holding tank. It goes via a centrifuge which spins and separates the oil and the metal particle and the grit. And then what oil is left over ends up in the holding tank. I cleaned that before I started, so it'll be interesting to see how much material got caught from honing out this barrel. So let's take a look. Take us over to the bed. Whoa. Considering this was empty before I started, it actually has a pretty good amount of grinding stones and metal material in it. So the more material the centrifuge catches, the better it is for what is stored in the holding tank. You don't want extra material floating around in there because it will end up gumming up the pump and the filter on the bottom of that. What I need to do now, I need to get this out of the hone, I need to give it a clean down really quickly, and then we're going to take it back over to the lathe. Righto guys, so we've got our barrel end fitted into our new barrel. The barrel ends are an interference fit, so I did have to apply just a small amount of heat around that in order to expand enough that I could then push the barrel end in. So we've got that in, we've got our alignment right, and we have the length of the barrel right. What I do have to do though, while I've got it set up in the lathe, I do have to give myself just a little bit more weld prep here. There is one area I just don't want to risk it, so while it's here, I can machine that out and know that I have enough room to get the tip in there and the nozzle and get a really good weld. So while I was machining that, I noticed there was a few things that didn't look like they were in alignment. I actually had to double check to see if the barrel end was in the barrel correctly. And what I worked out, it's actually the casting that makes it look like it's on the piss. This part of the casting is nice and straight, and the opposite side has actually got a big lump in it. Everything's lined up the way we took it apart, so it is just an optical illusion, and that's just sometimes how castings come out from the factory. And one other thing that people mentioned in part one was, why am I measuring the barrel in imperial? Well, that is because this is a yellow machine, it was made in America, and everything was built in imperial. So the cylinder size is imperial, the bearings, the threads, so on and so forth. Rather than convert them over to metric, which the ID of the barrel would be 292.11, it's easier just to say it's 11.5 inches. So that's all in place now. What I need to do is put a couple of tacks around that, then I can take it out of the lathe and go and get it set up for welding. Righto, so I'm about to weld the barrel end onto our new barrel. Because it is a cast component, I'll be using a different wire than what I use to weld on the head flange. The head flange, I use a metal cord wire because it is hollow bar going onto ST52 tube. But for a cast item, I'm gonna move over to my Hobart XL525. It is a dual shield wire. It is a much better material match for the cast items. And the gas we're gonna be using is an Argo Shield Heavy, so that's 80% argon, 20% CO2. I'll be running that at about 28 volts and about 6 meters of wire a minute. Righto guys, so all of our work on the 785 hoist barrel is now complete. It now looks 100% better than it did when it came in. We're not going to paint it. Our customer has their own paint facility and employees to do that. So even though it is a lot of work to rebuild one of these cylinders, it is less than half the price of a new part, and the customer can have this one back within a week, because at the moment it's going to take about 3 months to get a new one here. So we're going to get this one back to our customer. Job's done. Thanks for watching. One go, you ready?
Yeah.
How you going guys? Curtis from Cutting Edge Engineering. Today's job will be the... Oh, fuck. How you going guys? Curtis from Cutting Edge Engineering. So today we're gonna... Oh fuck. Right, ready?
Yeah.
Ready?
Yeah.
You ready?
Yeah.
Right, you ready?
Yep. Always ready.
Stop laughing. This isn't funny, right?
Are you ready?
I think so. Yeah.
Oh my god.
Right, so I'm just going to machine that out just so I can get the tip in and take it over to our welding rotator. Take it over to our welding rollers.
Oh my god. Should just be like, and it's flipped. These are cool.
Earrings of death.
Oh, lovely. Okay. Oh my god, be careful. Don't fall over.
Right, ready?
Yeah.
Noises.
Alright, try again.
Right. Righto guys, so I've got the barrel
Oh my god.
Yeah, fuck you fucking multi-wheel fucking... Fuck off, train. Right, so that's all the machining done, but before I can pit... Right. Right. Sweet fucking help, please. Right, so the more it catches, the less of it... Oh, fuck. Right. Right, so the more the centrifuge cap... Oh, fuck.
Oh my god.
Right, you ready? Right.
I'm ready.
Right. Right. So the... Fuck it.
If you say right extra, it might help, I reckon. Yeah.
Right. Right, ready?
Okay.
Okay, stop laughing at me.
Okay.
Right. Okay.
Okay. Oh, I need a break.
I'm going to be running that at about 28 to 29 volts at 6 to 6.5 meters of wire a minute.
Oh, I wasn't even recording that. Yes, I was. Yes, I was.
I put on my thinking cap and it went sweet. So, job's done. Thanks for watching. It's time to get Barry home. See you, Barry.
Bye, Barry. He's just killing all the squeakers. Oh, that one he crunched. Dead. Wait, which one haven't I killed? He's killed them all? No.